Hi there and welcome. We're looking at solving systems of equations with three variables. And with three variables, that means we'll need three equations. There are several different situations that can arise. Case one is our regular situation where we have an answer. We'll have an answer, we'll have an x, we'll have a y, we'll have a z. They cross. We will know what that point is, where they all three of them have an x, y, and a z the same, and it will be great. We will love this. Case two is one of those weird cases where they have no x, y, and z in common. So on this one, when you have an inconsistent system, you will find something happens and you will get a not true statement. When you get this not true statement, that means that they have no points in common and there will be no solution for this guy. Now, on this third case, this is when basically they all intersect in a line here, and you'll be able to give a list of X, Y, and Z's that work, and there'll be a whole bunch of them because they are a dependent system. So it's when they intersect in a line, you'll be able to give that equation for the line, and that's what they'll be looking for. They'll be looking for some sort of line equation. In case four, that's where two of the situations will be parallel lines, but you're going to have a third one that's going to intersect. So while you have no points in common, you are going to have a situation where one of those planes crosses both of them, and we will get a chance to look at all of these different cases. So let me remove that. So let's look at our first example. I'm going to choose two equations to begin working with. Doesn't matter which two. So I'll just number them, even though I don't really have to number them. I'm just going to number them 1, 2, and 3, just so that you'll know which ones that I'm looking at. I'm going to start with equations 1 and 2. And like I said, it doesn't matter which ones you pick. I chose 1 and 2 because I saw that if I add them, my y's will disappear. And I thought, ooh, that's a good place to start. But you could start with any two equations. But I'm going to add these two equations, and I'm going to make the y disappear. So notice this, 2x plus 3z equals 5. All right, so I chose to make the y disappear. Now, because I chose to make the y disappear, I am going to need to continue making the y disappear. So let me write that down for you. Okay, so the next thing I'm going to do is I'm going to choose two equations from my original, and they can't be, since I chose numbers 1 and 2, I can't choose 1 and 2 again. So I'm going to choose, let's say, 1 and 3. So I'm going to write down equation 1. And then equation 3. And these are set up so beautifully because I don't have to multiply or divide both sides by anything in order to use my elimination method. I can just sit here and add. It's really cool. So that's 2x minus 2z equals, 0. That's really pretty too. So let's look at what I have. I have this new equation, and I have this new equation. I'm going to take those two, and I am going to use techniques that I have been doing previously, and I am going to solve for either x or z. So let's scoot this up a little bit further. And let's say I'm going to take these two equations and decide what I'm going to eliminate. I think I'm going to choose the x, because if I write down, we'll call this as are the two equations we're looking at. So if I write down 2x plus 3z equals 5, and I look at this next equation, 2x minus 2z equals 0, I say, what can I do to these two equations? I can't add them like this and make a variable disappear, but if I multiply this guy through by a -1, those signs change, and when I do that, my x's drop, and I'm left with 5z equals 5. Well, that's pretty convenient. If I divide both sides by 5, I'll see that z equals 1. All right, I'm a third of the way there because I now have that z is 1. All right, so let's write down my step that I used to get to this point. All right, so I've written down what I did there. Now I have this z equals 1, which is one of my answers. So I can use any one of the 5 equations that I have, my 3 original or either one of these two. I'm going to choose to use this one right here, because if I do 2x minus 2z equals 0, and I substitute in z equals 1 because I know that's what it is, I'll be able to tell you what x is. So 2x equals add 2, and x is 1. Now I can choose any one of my 3 originals to plug this into. I'm going to choose equation 1. I like it when they don't have negatives, and that one was x plus y plus z equals 4, I think. And this will allow me to get my y. I'll just say x is 1. I don't know y. Z is 1 equals 4. Y plus 2 equals 4. Subtract 2 from both sides, and you get y is 2. Now, they might want you to write your answer in that form of x equals y equals z equals, but they also might want it as a coordinate point. So they might want it to look like, let's see, you write the x first, so that would be a 1, then you write the y, and then you write the z. So they might want it to look like a coordinate point where you place x and y and z in there. And they're going to give you several different ones of these that you're going to try. Some of them have fractions. Some of them are easier to solve one way than another. You get pretty good at solving them the more you work with them. With anything, the more practice you have, the better you get at them. And yeah, I know when you first start working with them, they do take a long time. So sorry about that, but I will tell you that they get easier. The more problems that you do, the easier they get. So let's work another one where I do one of those strange cases that happen. All right. So here's another one that we're going to look at. Let's just say I want to look at equations 1 and 2. So I'll number them again. Well, not that you have to, but I'm just going to do it just so that you can follow me. So I'm going to write down equation 1. And I'm going to look at equation 1 and equation 2. I'm going to try to decide which variable would be the easiest to make drop. I can choose x, y, or z. It really doesn't matter. It's all the same. Well, you'll end up with the same thing, but sometimes it's easier to do one than another. I'm just going to say I'm going to pick z. So I'll just say I'm picking z as my variable to eliminate. That means I'm going to multiply this equation through by a 2. And this stuff involves a lot of writing. So just prepare yourself. So this is going to be 6x plus 2y, just multiplying all the way through, 4z equals 14. Now I'm going to add. That's a little bit of a sneeze there, sorry. Okay. All right, so there's equation 1. Now, I'm going to pick, say, equations, let's just do 2 and 3. And let me write them down. So 2 and 3 are going to be 3x plus y minus 2z equals 7 minus 9x, 3y plus 6z equals 5. And I chose to make the z's disappear, so that means I have to stay consistent with that. I'm going to multiply this equation through by 3. Let's see what I get. I get 9x plus 3y minus 6z equals 21. Negative 9x plus, oops, not plus, let me hit my back there. Minus 3, I can't copy. Plus 6z. I was just looking at what was going on the out compared to the top there, because notice you're gone. I get 0 equals 26. This is not true. It means it doesn't matter what your x's and y's and z's are. This is not going to happen. What this means is no matter what I do, I will not get an x, y, and z that are the same here. So what I do is I say that this is an inconsistent system. And that's how we'll leave this. All right, we'll do one more weird case. Here's our next problem. I need to choose two equations. Doesn't matter which two I pick. I try to look on the front end, make my life easier. Looks like x's might be the easiest to make drop, so that's what I'm going to choose. So I'll make x's drop. I need to choose two equations. I will choose equations, I'll call them 1, 2, and 3. I'm going to choose equation 1 and 3 first. So here's my 1, 2x plus 3 minus z equals 5. X minus 4y plus 3z equals 5. And I'm going to multiply this bottom one through by a negative 2. And that should make my x's drop. So copy down my x one once again. Z equals 5 minus 2x. And this should be plus 8y minus 6z equals negative 10. Chunk. And then we get 11y minus 7z equals negative 5. So there's equation 1. Let's go look at equation, the next one that we're going to make. So I'm going to use equations 2 and 3. So equation 2 is 4x plus 6y minus 2z equals 10. And x minus 4y plus 3z equals 5. I'm going to multiply this bottom equation through by a negative 4 so that I can make my x's drop. So let's play. I've got to write down this top one again. Minus 2z equals 10. Minus 4x plus 16y minus 12z equals negative 20. These problems are so long. Let's see, this is 17y. Nope, that's not 17y. That's 22y. Wonder what I was thinking. Let's see, they get that off there. 22y minus 14z equals, and that's going to be negative 10. So here's my other equation. Now I'm going to look at these two equations, and I'm going to say, okay, if I multiply this one here through by, say, a negative 2, it would make the y's drop. So let me write that down. Negative 22y plus 14z equals 10. Let me copy down the other one. 22y minus 14z equals negative 10. Oh, you're a 0. You're a 0. You're 0. Oh my goodness. I have 0 equals 0. While this thing is true, no matter what you do. So when they're true, no matter what it is that you do, what's going to happen is we have this dependent system where we have one line and it has an infinite number of solutions. So for this textbook, all they're wanting you to write down is that it is a dependent system. And that's all they need you to do for this one. They don't need you to go further with it. Eventually you'll be able to go further, but not in this one. All right. If you need for me to work a few more of these for you, just be sure and ask me for a collaborate. I'd be happy to do that for you. And you can watch me work through several of these. These problems are long. If you make a mistake up here at the very beginning somewhere, the rest of your work is just garbage. So really be careful with what it is that you're doing, because you don't want to make a mistake here. Even I found that most students, a lot of time what they do is they've made a mistake in copying, and so you don't want to make a mistake there, copying something down wrong, and then the whole rest of this be garbage. And it will take up a lot of paper if you're making those reckless errors, and it takes you a lot of time. So be very careful on those. And just let me know if you need me. All right, email me. Be glad to hear from you. Have a wonderful day.